Suppose we have a differentiable function f. We want to find the maximum and minimum value. So just by looking at this, we can tell that this point is a maximum, and this point on the endpoint will be a minimum. To be more precise, this will be called the absolute maximum, and this will be the absolute minimum. Notice that there are other interesting points here and here, which are minimums in a small neighborhood. So these points we will refer to as local maximum and local minimum. Now, this absolute maximum is also a local maximum as well. What we notice is that the slope is 0 on the local max and minimums. So at the local maximum, the derivative is 0. So to find the absolute maximum and minimum on a function, what we can do is try to find the local maximums and minimums and also test the endpoints, and the largest of them will be the absolute maximum and the smallest will be the absolute minimum. So let's try an example. To find the absolute maximum and minimum of this function, x cubed minus 3x squared plus 1 on the interval -1/2 to 4, what we'll first do is find where the derivative is 0. Such a point is called a critical point. Let's take our derivative. We get 3x squared minus 6x, which factors into x equals 0 and x minus 2. So x equals 0 and x equals 2 are the critical points. We also note that the endpoints are x equals 1/2 and x equals 4. So now we test all the values. So now we'll plug in these values into f of x. Plugging in -1/2 into here, we will get -1/2 cubed minus 3 times -1/2 squared plus 1, which is 1/8. Plugging in 0, we'll get 0 minus 0 plus 1, which is 1. Plugging in 2, we'll have 8 minus 12 plus 1, which is -3. And plugging in 4, we'll have 64 minus 3 times 16 plus 1, which is 17. So our absolute minimum is the value -3 at x equals 2, and our absolute maximum is 17, which is at the endpoint. So to sort of sketch this graph, it must have looked something like this, where you have a local maximum and a local minimum. This local minimum is an absolute minimum as well, and the endpoint is our absolute maximum.